All right, so today we're looking at converting between two different forms, algebraic forms of a quadratic function. So standard form is sometimes called simplified form, where there are no brackets, all like terms are collected, and it's shown in descending order of degree. So ax squared plus bx plus c. Okay. Vertex form is where from this form you can figure out what the vertex is, which we've talked about already. So the vertex here is PQ. It's the opposite sign of the constant term when the coefficient of x is 1 in the bracket, and Q is your y value at the vertex. Okay, so we can convert in between. Obviously, going from vertex form to standard form, pretty straightforward. You expand to get rid of the brackets and collect like terms. Going the other way is a little bit harder. So that's what we're going to look at, some patterns and figure out what to do. So here, converting from vertex form to standard form, just need to expand the square of a binomial. And remember, there's 3 terms when you square a binomial. Okay, so don't forget about the middle term. So you square the binomial and multiply through by any coefficient in front of the brackets, and then add any constant term at the end. So squaring a binomial results in a perfect square trinomial. That's what we call these, because we can factor it to a binomial squared, which is a perfect square. Okay, but these are trinomials. So that's the word, the name that's given to them. To get the 3 terms of the perfect square trinomial, you have to square the first term of the binomial, multiply the 2 terms of the binomial together and double them. So this is back from Math 10 last semester. And then you square the last term of the binomial, or second term, I guess, because there's only 2. Okay, so the first and last terms will always be positive in a perfect square trinomial. Use a shortcut to squaring to expand the following. So back in Math 10, you may have done it the long way, shown it as x plus 8 times x plus 8, and then used FOIL to get your 4 terms, and then collected like terms. You don't want to do that anymore. You're in Math 20 now. You need to be able to do this the quick way. So x squared, first term squared, the product of the 2 terms doubled, and then the last term squared. Okay, first term squared, product of the 2 terms doubled is negative 18x, and then the last term squared is positive 81. First and last terms are always positive. All right, so convert to standard form. Order of operations says we have to do our squaring first. Then multiply through by 3. What's that? 18, 8. And then collect like terms. So that's 91. Okay. Next one, again, square the binomial, so x squared plus 8x plus 16. Multiply through by negative 1/2. And then collect like terms. Okay, I often show this as negative 1/2 rather than negative x squared over 2, just because that leading coefficient is important when you're graphing. It tells you the stretch factor, the reflection, and so it helps you in graphing. Whereas when you show it as negative x squared over 2, you might miss something. It's totally correct, but I would keep it sort of more as an obvious coefficient. Okay, going the other way is a little bit harder. In order to convert from standard form to vertex form, we need to express a perfect square trinomial as a square of binomial. We have to work backwards. So we need to figure out what the third term is that would make a perfect square trinomial, because we're not always going to have that. So examine the first two perfect square trinomials to determine the relationship between the coefficient of x and the constant term. Also determine the relationship between the perfect square trinomial and the binomial for which it is squared. Use your conclusions to complete the last row. So here, x is the root of x squared, 5 is the root of 25. Remember, the root of each of these doubled gives you your middle term. Here, same thing, root is x, root is 8. Product of those doubled is 16. So here, if we don't know what that last term is, this middle term in both of these is twice the product of the root of each term. So here, divide this by 2 and we get negative 12x. So we need to have an x. There it is in the negative 12x. And then negative 12 needs to be the root of this term. So really, that has to be 144. Okay? So this is going to be x minus 12. So x squared, product of these two doubled is negative 24x. Negative 12 squared is 144. Okay? So that's going to be 144. So you want to take half of the coefficient of the x term and square it. So to determine the constant term that completes a perfect square trinomial, so divide the coefficient of x by 2 and then square that result. Use your relationship to determine the constant term that makes each of the following a perfect square trinomial, and then express each perfect square trinomial as a square of a binomial. So take half of 12 is 6, squared is 36. Half of negative 20 is negative 10, squared is 100. Half of 7 is 7 over 2, squared is 49 over 4. Leave it in fraction form. So then this would be plus 6. This would be minus 10, whatever sign is in front of the x term is the sign in the brackets. And then this would be plus 7 over 2. Okay, so you can always get it from half of the coefficient of x or the root of the constant terms. So convert each of the following to vertex form. So notice how this is not making this a perfect square trinomial. So what do? Keep the x terms together. I'm going to show the subtract 5 at the end. Now what I want to do is I want to take half of 8, which is 4, and square it. Actually, I'm going to do it in red. Is 16. Now I've changed the equation. Okay, so what I want to do is subtract 16. And I'm going to put that in brackets. So I'm adding it and subtracting it. Then I'm going to move the brackets. Okay, so I'm bringing this negative 16 out. There's nothing in front of the bracket on the left. It's a 1, so it's worth negative 16 when I bring that out. And now I can factor. The bracket, negative 16 minus 5 is negative 21. Okay, so that's vertex form. You can check by graphing both. Oops. So if you go to y equals, clear it, and enter x squared plus 8x minus 5, and then also bracket x plus 4, close bracket, squared, minus 21, and then you want to go, just do this on a standard screen. Actually, the vertex is going to be negative 4, negative 21, so I'm going to go to Window and make my y min negative, say, 25. So there's the original graph, and then my new graph should go right over top. if you've done the algebra correctly. Okay, so we know we have. Next one, notice how there's a 2 in front. So we actually have to factor out a 2 because we always have to have 1x squared in the bracket. So that's going to be x squared minus 6x. Leave the 7. Okay, do not include that constant term. Very odd time, maybe it's a perfect square trinomial to start, but most of the time it's not. So factor out the 2, so you haven't changed anything here. Then take half of negative 6, which is negative 3, and square it, which is 9. So you add it and subtract it. I like doing it within the brackets, add and subtract, and then I deal. You can take fewer steps, but I like to show each step separately. So x squared minus 6x plus 9. And now I can't just show this minus 9 outside of the brackets, because really what it's worth is minus 18. Okay, so you need to expand just the 2 into that last term, not into everything else. Then you can factor that bracket, because it's perfect square trinomial, and collect like terms, and there you go. And then you can graph both to check. Next one, there's just a negative out front, so I'm going to factor that out. Then half of 7, negative 7 is negative 7 over 2, squared is 49 over 4. Add and subtract it. Okay, this is always going to be adding, because when you square a negative, you get a positive. So you're always going to be adding and subtracting. And now, if I show it with brackets, and now a negative times a negative is a positive. And then factor that. And now with the like terms here, common denominator is 4, so that would be 49 minus 16 is 33 over 4. Okay, always leave it in fraction form, unless it's an application question. Next one, negative 3 has to be factored. Now notice that negative 3 doesn't go into 10. So we have to use fractions. So that's going to be negative 10 over 3x. I'm going to move this just a sec. Let's try to make it a little bit smaller here. So y equals, okay, and then half. So you're taking half of negative 10 over 3. Do it on the side if you need to. That's negative 5 over 3. And then we have to square that. So that's plus 25 over 9 minus 25 over 9. Okay, if you take the root of that, you get 5 over 3, which is half of 10 over 3. Okay, you know you've done it correctly. And then, as I said, half of 10 over 3 is 5 over 3, so that's your constant term. Now, when you expand this back, that's going to be plus, and 3 goes into 9, so that's going to be 25 over 3 minus 2. And common denominator of 3, so that's going to be 25 minus 6 is 19 over 3. Okay. Next one has a fraction out front, so we need to factor out the fraction. Okay, now when you factor, you're dividing by a half. So when you divide 3x by half, you actually get 6x, not 3 over 2. So that's a common mistake that students make. Okay, oops. So now I take half of 6 is 3, squared is 9. So add it and subtract it. When I multiply through by a half, I get negative 9 over 2. That's going to be x plus 3 squared, and then common denominator of 2, so that'll be negative 9 minus 12 is negative 21 over 2. Okay, if you're not sure, let's graph and check this one. Okay, so go to your y equals, clear off. Your first one was 1/2 x squared plus 3x minus 6. And your second one, your Vertex version, okay, and then we could probably, let's just graph it with the window that I had from before. And it's going right over top. So I know I haven't messed up the algebra. Okay, and then this last one has decimals. So that means if there's decimals in it, you can use decimals in your work. So we want to factor out 1.2. So what's 6 divided by 1.2? That's 5. I should have known that. Anyway, you probably got it faster than me. And where's my, sorry. Okay, so that's going to be 5. It's going to be minus 5x. There is no constant term right now. Take half of 5. Now, because there's a decimal, if you take half of 5, you can use the decimal form. That would be 2.5. Negative 2.5 squared is plus 6.25 minus 6.25. When I multiply through, so then I've got to take my 1.2 multiplied by negative 6.25, and I get negative 7.5. What did I just say that was? Negative 7.5. Yeah. Okay, so 1.2, that's going to be negative x minus 2.5 all squared minus 7.5. Okay, and so you can find the vertex of all of these. Remember, opposite sign of the constant is your x and in the brackets, and then the constant outside of the brackets is your y at the vertex. And that's it.